Hello, my name is Dr. Cooper and I'm a physiologist working at the Birmingham City University. Welcome to this laboratory session on the dissection of a heart. Basically, the heart is a specialized pump, and it has a sort of mechanism whereby it has to pump around fluids in the body. And these include the gases like oxygen and carbon dioxide. Oxygen is necessary for respiration and for the production of energy. So cells certainly need oxygen, and the heart helps the delivery of this oxygen to the tissues. The heart also carries back, through its pumping action, a waste gas called carbon dioxide, and this is returned to the lungs and breathed out, or expired. The heart also, through its pumping action, delivers nutrients, and these might include glucose, vitamins, proteins, etc., to the cells that need them. The heart also, in its pumping action, ensures that waste products of metabolism are returned to places like the kidney, where they can be filtered out and excreted. So the heart is, in essence, an essential organ of life, and we'll see in a bit that it's very specialized in order to achieve these roles. The heart is a very specialized organ, and in order to help one look at it and dissect it, one needs some guides, and a very useful guide is a photographic atlas of the body. And this is very, very useful because it has very real images and very nice images in color that one can page through and use as a reference when looking at an organ. For example, the heart itself, shown in the pictures here, has been dissected to show a variety of structures. And what's nice about these images is that the views, the sections and the views, are indicated on each of the diagrams. Here, illustrated in this book, is a picture of the heart, and its view is shown below. Very detailed labeling, and it's been in color. One can see what a heart looks like when indeed it's outside of the body, and the various structures in the heart have been identified, and one can certainly use this as a useful reference source when one is dissecting the heart. Our lab has a number of these reference books which you're very welcome to use during the dissection, and this is another one, a brief atlas of the human body, a very useful resource. It has a lot of thoracic views of, for example, the heart in the chest cavity. These images shown here are of the anatomical view of the heart in its thoracic cavity, and you can see a variety of major blood vessels and other structures like the lungs. So hence it's a very good resource to see the location of the heart in its thoracic cavity. This is the dissection trolley, and we need to sort of go through a few of these items on the trolley because they're essential parts of any dissection, including the heart. And what we've got here is a tray, and this tray sort of has a number of dissection instruments on it, and these are really important to help you, to assist you when dissecting the heart. These two are sort of round-ended probes, very important and useful for probing into blood vessels like the coronary arteries and also in the chambers of the heart. We've also got a variety of forceps, a sort of fine-tipped and a blunt-ended pair of forceps. We've got a pair of dissection scissors, and we've also got a pair of clamp forceps, and finally a scalpel. Here in the front is a ceramic tile that we very useful for placing an organ on when observing it and dissecting it. We also need the water, which we'll spray on the organ in order to prevent it from drying out. What we're going to do now is go through the heart together, and this is an ox heart. And what we're going to do is sort of have a lift of it, and sort of, once you've got your gloves on, you're very welcome to lift it, and sort of place it gently on the tray, and we're going to now examine the outer surface of the heart. But of interest, before that, if you just like to lift it, let's lift it like that, and it's surprisingly quite heavy. And if you sort of estimate, it's under 2 kilograms by 1.5 kgs. The heart has a number of, like any organ, a number of views, and these are important to note before the dissection begins. This is the anterior view, sometimes called the frontal view, and if we just turn the heart around there, that would be the posterior view. The view on the sort of top bit of the heart, just there, is the superior view. And you can see a variety of blood vessels there. And if we turn it around, the end bit, the apex of the heart, there is the inferior view. Let's spray the heart with some water, just gently, in order to prevent it from drying out. It's always important. And now we're ready to have a look at the outer surface of the heart. The heart itself has, as you see, quite a lot of fat there, and the fat is quite thick there, as you can see. And if you sort of have a feel of the fat, it's rather tough, very sort of hard, compared to the tissue of the heart, which is soft and sort of smoothish. You would also notice that on the outer surface of the heart there are extensive sort of blood vessels running down the side of the heart, and some of those over there. And these are branches of the coronary artery and also branches of the great vein. We can also, if we sort of turn the heart around to look at the posterior view, notice that this sort of smoothish area is covered by a very sort of thin membrane, the pericardial membrane. And this membrane is important, as you can see it there. It's sort of very, very thinnish, but tough and flexible. This membrane is a serous membrane, and it's important to reduce friction. Certainly the heart will be moving when it beats, and if we limit the friction with the pericardial chamber of the heart, that's the heart cavity, then the heart won't suffer any ill effects. Also notice that the fat, the visceral fat, sort of runs sort of down the, sort of follows the branches of the coronary arteries. In a way, the fat sort of helps to sort of, in a way, protect them, and because they're quite close to the surface of the heart. And the fat as well acts as a reserve of energy for the heart. The heart itself is beating without tiring, and that's due to a specialized sort of muscle. we can use a probe to have a look at one of the branches of the coronary arteries, the interventricular branch, and on this posterior view of the heart, I've already made an incision at that point. And what you can do is use the larger rounded end probe and insert it into the coronary branch there, and if you just twiddle it gently from side to side, you can slowly insert the probe up the length of the blood vessel. And as you can see, the blood vessel is really quite close to the surface of the heart. If we withdraw it gently, you can see some of the blood coming out there. So the coronaries certainly need to be free of any obstructions, and ideally they shouldn't get hard with cholesterol. They need to be carrying sufficient blood and nutrients, including oxygen, to the heart as it's beating, and also to carry away the wastes of metabolism. If we have a look here at the heart, it's been dissected for us, we can see how thick the fat is there. And especially there, it's very, very thick, isn't it? So much thicker at the top part of the heart. But if you sort of use the probe to move some of the fat aside, you can start seeing some sort of blood vessels there. And these are the branches of the coronary artery. This is the left side of the heart, so these would be the left coronary arteries. This would be the right side of the heart. And if we turn the dissected surface over, and with the probe so placed in there, we can sort of see a branch of the great cardiac vein. So the coronaries are supplying oxygen and nutrients to the heart, and the vein is carrying away waste products. If we look at the myocardium of the heart, by opening it there, the left side of the heart has a very thick wall, so the myocardium is very thick there, compared to the right side of the heart, which is a much thinner wall. The left side of the heart has to pump blood systemically, so the left ventricle has to create enough force to pump blood throughout the body, hence the thickness. So the greater the thickness, the greater the power generated during contraction. The right side of the heart has to pump blood to the pulmonary circuit, so blood back to the lungs, and as the lungs are next to the heart, it's a shorter distance, hence less power is needed. So if we open up the heart there and look at some of the chambers, and if you sort of put your finger on there, notice how smooth the chamber is. Okay, and this first bit here would be the atrium, the left atrium, and you can put your finger further down, carry on, and you go down into the left ventricle. So it's got a very smooth surface. It's important for the flow of blood. Okay, we don't want any sort of obstruction to the flow. The left atrium leads down to a valve, which is here. This is the valve, and this is the bicuspid valve, and attached to the valve are these very tough sort of fibrous strands, and if you put the probe there and sort of pull it gently, you can sort of feel how tough they are. Try some there. There you go. Quite tough. These are the cordae tendinae, and they are in essence helping the valve stay in its position. And what they're doing is they are sort of allowing the valve to open and then shut. So the blood flows through and then they shut. So they don't flap about. So those valve flaps are opening with the flow of the blood. And the tension provided by the cordae tendinae allows them to close. as I said before, the left ventricle has to receive the blood from the left atrium, and when it fills, it's sort of going to expand itself out a bit, stretch itself out. And there are some, move the heart like that, there are some, if you hold it, the myocardium to one side, you can see some sort of strand-like, sort of bumpy bits there, and these are the trabecular carneae, and these trabecular carneae are quite useful to allow the chamber to stretch itself. So as it fills with blood, the chamber stretches. And these provide that ability to stretch. The recoil of the heart as it contracts is also important in order to generate the power to force the blood out of the heart into the various blood vessels. We can go further and look at the other side of the heart there, and again with your probe you can sort of see the valve there and further chordae tendineae, and this valve would be the tricuspid valve, and it's sort of allowing the blood, as when it opens, to flow from the right ventricle into the right atrium into the right ventricle, and that fills with blood and stretches. The two sort of atria fill with blood, and then when they contract, they force the blood into the ventricles, which then together fill with blood. So this creates a good rhythm to the heartbeat, a coordinated heartbeat. And part of that coordination is provided by this electrical supply to the heart, the Sinoatrial Node, which can be found in the posterior area, the back part of the right atrium. It supplies electricity to the heart, which runs down the Intra septum all the way down to the apex and radiates outwards. So the electricity, the nervous impulse, is allowing the heart to beat in a coordinated fashion. Let's look at the blood vessels on the surface of the heart. This is a branch of the great vein running down the surface of the heart. Here we have some of the coronaries. And these coronaries would be the anterior, so the front view, the anterior, Interventricular Branch. The branches have a sort of, at different points, they have a bifurcation, so they branch into two. And this is allowing the delivery of blood into the tissue that needs it. So hence, very important that there are no blockages through deposition of cholesterol. There's no hardening of the coronary arteries. And indeed, there's no blockage of the great vein. It's carrying away the waste products of metabolism away from the heart, so there shouldn't be any blockages. The coronaries actually begin in a section of the aorta. And what we're going to do is look at the superior view of the heart and discuss some of the great blood vessels seen there. First thing to notice is this is the left side and this is the right side of the heart. And what we're going to look for is the aorta, and there's a section of it there. And notice how thick that artery is. The aorta is the largest artery, and it's carrying blood at high pressure from the left ventricle to the rest of the body. And if you put your finger in there and just rub it along, it's got a very smooth surface. Also important to reduce friction that might otherwise cause a clot to form. So we don't want any friction present. The aorta actually branches, it's not shown here, but it actually branches just over the top of the heart there into three arteries: the brachiocephalic, the left common carotid and the left subclavian artery. But the other blood vessels that are of interest include the pulmonary. So look here, this sort of section there, sort of there. We've got a vessel quite close to the aorta over there. This is the pulmonary vein. It's carrying blood from the lungs back to the heart, so it's rich in oxygen, and it's carrying oxygenated blood into the left atrium. If we move across to the other side of the heart, the right side of the heart, we can also see a number of other blood vessels, and here we can sort of see one of them there. It's much thinner than the aorta, and that would be part of the vena cava, and this is carrying deoxygenated blood back to the heart, and this would enter the right atrium. The blood, once it enters the right atrium, would need then to be pumped into the right ventricle, and the right ventricle is only going to pump the blood out through an artery, and here's part of that artery, also thick-walled. And this is the pulmonary artery. It's carrying deoxygenated blood back to the lungs. The reason it's an artery is to speed up the flow of the blood back to the lungs. In other words, we want to get rid of the carbon dioxide as quickly as possible, so deliver it quicker to the lungs. So there we have the superior surface of the heart and the major blood vessels. This concludes the dissection of the ox heart. We're now going to have a look at a pig's heart, and it's much smaller than the ox heart, and here it is ready for us. Let's lift out the pig's heart and place it on the ceramic tile, and what we need to do is spray it with water, and this is in order to prevent it from drying out. Just a little bit of water. And again, it's sort of a very important organ, an organ that pumps blood around the body, carrying oxygen and waste gas, carbon dioxide. If we sort of lift it up, it obviously weighs less than the ox heart, but about 0.3 of a kilogram, thereabouts. It's got its fat on its outer surface. The fat is there, and some of it travels down the length of the blood vessels. So we've got the anterior view. Turn it over. Posterior view. And the apex is the inferior view. And the top part of the heart is the superior view. Again, we can sort of have a feel. The fat is rather tough to feel. Just poke it there. And the fat sort of is around at the top part. It's fairly thickish compared to the size of the heart, supplying sort of the heart with some source of energy. And the myocardium is a lot smoother and sort of more flexible. So have a look at this heart, and the same procedure, sort of look at the various sort of chambers and see the branches of the great vein and the coronaries, the thin membrane, and have a look at the thickness, the left ventricle, fairly thick wall, and this sort of dissected area is quite useful in that it shows a good appreciation there of the cordia tendini. Those tough fibers that hold the bicuspid valve in place. The left atrium is again pumping blood into the left ventricle, which then has the job of pumping blood to the rest of the heart. So have a play with it, and also have a look at the various sort of blood vessels, and first of all, always try and look for the aorta, and if sort of go back to the sort of left side of the heart, so the aorta associated with the left side of the heart, and there we sort of have it there, part of it, and there's its wall, a thickish wall, and a very elastic wall, that's the aorta. So please have a look at all the views of the heart, and have a look if you can, to see if you can identify the various blood vessels and the chambers of the heart as well. Make sure you're also able to label the heart and follow through the various sections in your dissection books. This concludes the dissection of the heart. I hope you enjoyed it. I certainly did. And you're very welcome to come and see me if you've got any further queries. My name is Dr. Ross Cooper, and I'm located in Bevan House, 030 Bevan House, that's the ground floor. And my email is ross.cooper@bcu.ac.uk. Thank you very much for your time.